Hi, and welcome to this tutorial about descriptive stats. What I want to cover in the next 9 or 10 minutes or so is what are descriptive stats, and then talk a little bit about measures of central tendency, statistical dispersion, and distribution. So that's our topics here for this tutorial. Okay, what I've done is I've sort of created a few sample data sets. I've created 5 sample data sets here, numbers between 2 and 8, and I've basically here plotted figures that graphically represent the distribution. These are called frequency distributions. And so this is my data set here, and I've got 4 other data sets. You can see they're slightly different. Now, descriptive statistics are a way to summarize large sets of data into a few simple parameters that describe the larger data set. Specifically, descriptive statistics try to describe 3 characteristics of the larger data sets: the central tendency, the statistical dispersion, and the distribution. The central tendency is the concept that there's one number that best describes the entire set of data, a number that's central to the entire data set. There's various measures that can be used to illustrate the central tendency, but the most commonly used ones are the mean and the median. Now you'll remember the function for mean in Excel is equals to average, and then you highlight your data set. So equals to average of that, and for median is median, equals to median of the data set here. So this distribution here has a mean of 5 and a median of 5. I can drag that across to see what it looks like for my other values. This second distribution has a slightly lower mean of 4.5, 5.4, same mean of 5, and a mean of 5 for this one. For median, interestingly enough, they all have exactly the same median. They all have a median of 5. So this highlights a little bit. See, this distribution and these two have the exact same mean, the exact same median. They're clearly not the same distribution. So we're missing a descriptive. The second description of this frequency distribution that descriptive statistics try to provide is a measure of statistical dispersion. It describes how spread out the measurements are from the central tendency. Some commonly used measure of statistical dispersion include the range, the standard deviation, and the coefficient of variability or coefficient of variation. Now the range is very simply the maximum value minus the minimum value. So again, remember the Excel functions equals to max of my data set minus the min of my data set. Now I can see it already now because of the way my data is organized. It's basically 8 minus 2 should be 6. Ah, great, it works. Okay, so there it is. Standard deviation, you remember the Excel function is actually stdev, so equals stdev of my data set. There we are. And then for the coefficient of variation, slightly different. Coefficient of variation is calculated by dividing standard deviation by the mean. It's usually expressed as a percentage, so this is 26%, or I can show it directly as a percent by moving up here in the home ribbon and clicking on percent. It's 26%. And again, I can drag it across. Whoops! I can drag it across to all 5 distributions. Now they all 5 have the same range, 6, but the standard deviation and the coefficient of variation vary slightly from a low number to a higher number. Now, I'm still missing something. To describe a large data set, we also need to know a little bit about the distribution of the data. For example, from the central tendency, we know the central point of the distribution. And from the statistical dispersion, we know how spread out it is. But now we need to ask, how evenly spread out is this data? Now, in biological sciences, very often you'll find data that are normally distributed, like here. Normally distributed, basically, it looks like a bell. We call it a bell-shaped curve. Now my bell looks a little sickish, so my data is not beautifully that way, but it looks like a bell. It's bell-shaped curve, and oftentimes you will actually hear it being referred to as the bell-shaped curve. Out of interest, environmental data is very often log normally distributed. So if you plot it on a log scale, it'll be that nice normal distribution. But that's a bit of an aside. Now, it is more difficult to express distribution in a number or two, but there are two values often used to describe the distribution. And these are called skewness and kurtosis. Now, the skewness is a measure of how symmetrical the distribution is. A distribution with a high skewness is highly unsymmetrical. So obviously, looking at the data here, we would expect this to have a neutral skewness. It's neither skewed to the left nor skewed to the right. It's very symmetrical, so it should have a skewness of 0. Whereas this obviously shows that from the median of 5, there's a lot more, there's more data on the left. And here with the median of 5, there's obviously a bump. The data is not symmetrical. There's more on the right. And so this should have a positive skewness value because it's skewed to the left. This should have a negative skewness value because it's skewed to the right. Let's see if that works out. There is, again, thanks Excel, a function specifically for that. In Excel, it's called skew. So equals to skew of my data set. There it is. And great, skewness of 0. So this is perfectly symmetrical data, and you can clearly see it. It's very symmetrical. And if I drag it across, this is a slightly positive skewness data, slightly negatively skewed data, and these two are again perfectly symmetrical. For kurtosis, it's a little trickier to explain what kurtosis measures, and you might want to ask your friendly statistics professor for the full version of this story. Tell him I sent you, he'll love you for it. But in a nutshell, it's a description of how flat the distribution is. So a value with a distribution with a really high kurtosis is a distribution with very sharp peaks. So, for example, here this is a very sharp peak compared to this very flat peak here, and this should have a much higher kurtosis value than this. So if we again calculate it in Excel, there's a function for kurtosis called kurt, equals to kurt of these numbers. And here the kurtosis is 0, so this is a nice normal distribution. And when we look at the kurtosis value for these two, you can see indeed it's a positive value here and it's a negative value here. So this is a much flatter distribution. This is a distribution with very high peak. Okay, so that's a brief primer on descriptive stats. We looked at measures of central tendency, we looked at statistical dispersion, and we looked at distribution measures.